Here's how we define radians. Okay, let's say you've got a circle, and this circle has a radius of r units, and you've got an angle which we'll label theta, and then on this circle this angle intercepts an arc of length s units. Then we define radians to be the ratio of this arc length over the radius. In other words, theta equals s over r. So for example, what's the measure in radians of a central angle that intercepts an arc of length 40 centimeters on a circle with radius 2 meters? The first thing you have to watch out for is to make sure that your arc length and your radius are the same units. And so if they're not, you need to convert them. Okay, so we have that our S is 40 centimeters. Our radius is 2 meters, which is 200 centimeters. So theta is going to be 40 over 200. You'll notice that my units cancel, so radians are dimensionless, okay? And I can reduce that to 1/5 radians. So how many radians is all the way around a circle? So let's say that I start here and I go all the way around to there. How many radians would that be? Well, all the way around is the circumference, which is 2 pi r, and so that's s, and we're dividing by r. So what happens is r's cancel, and a full rotation is always 2 pi radians. So that means that 360 degrees is 2 pi radians. If I divide both sides by 2, that gives a very useful relationship. 180 degrees is 1 pi radians. So we'll use that relationship to convert from degrees to radians and radians back to degrees. So let's do degrees to radians. To convert degrees to radians, multiply the degrees by pi over 180, since pi radians is exactly the same as 180 degrees. So here we go. 45 degrees times pi radians over 180 degrees. Well, 45 goes into 180 4 times. So 45 degrees is exactly the same as pi over 4 radians. To convert radians to degrees, we just flip our conversion factor. Instead of pi over 180, we're going to multiply by 180 over pi. So here's our example. We're going to convert 2 pi over 3 radians to degrees, which means I'm going to multiply by 180 degrees over pi radians. And you notice the pi's cancel. And 3 goes into 180 60 times, and we get 120 degrees. So 2 pi over 3 radians is exactly the same angle as 120 degrees. Okay, so if theta radians equals arc length over radius, then we can solve this for the arc length by multiplying both sides by r, and I get that the arc length is r times theta. You have to make sure theta is in radians, okay? So let's look at this example. In a circle with radius 10, so there's our r, an arc is intercepted by a central angle of 7 pi over 4 radians, so there's our theta. So find the arc length. Okay, well, S is equal to r theta, which will be 10 times 7 pi over 4, which works out to 70 pi over 4, which works out to 35 pi over 2, and the units are centimeters. So we learned how to do arc length. How about area of a sector? Well, the area of a sector of a circle with radius r and central angle theta is given by this formula. The area is 1/2 r squared theta, where theta is in radians. Okay, so let's say we've got a slice of pizza, and the pizza has a diameter of 14 inches. All right, that means the radius is 7 inches, and it's sliced into 8 pieces. Okay, so how much is 1 piece? So there's the problem. How much is 1 piece? Well, theta is going to be 2 pi radians, that's all the way around the pizza, divided by 8, because we're doing 1/8 of the whole pizza, okay? So that's going to be pi over 4 radians. All right, so the area of our pizza slice is going to be 1/2 r squared times theta, which is pi over 4. All right, so it's going to be 49 pi over 8, and our units are square inches because I squared my radius. Okay, that works out to about 19 square inches. So that's how much area that pizza slice is. Okay, and then finally let's talk about something called the unit circle. If a circle has a radius of 1 unit, it's called a unit circle. And your radians are equal to your arc lengths, okay, because r is just going to be 1. So it's going to be really useful if you can memorize these special angles in both degrees and radians on the unit circle. You'll notice that, let me get the whole circle in here. There we go. You'll notice that 0 degrees and 360 and 180 are in purple. All the multiples of 30 degrees are red, so that's 30, 150, and you see that's a 30-degree angle right there, and that's a 30-degree angle right there. So all the 30-degree multiples are in red: 30, 150, 210, and 330. All the multiples of pi over 4, these are 45-degree angles, are in blue. All the multiples of 60-degree angles are in green, and you've got your 90 up here and your 270 down here. Okay, so like I said, you're going to have to memorize all of these angles and their respective radian measures, because it will save you so much time and headache later on when we get into more trigonometry.